Welcome back, neighbors, to Mr. Dady's neighborhood. Today we are talking about using equivalent expressions to solve equations. All right? If you have looked on Odyssey, where it sort of glazes over the idea that you already understand integers. So if you do, great. If not, I'm going to go over it very quickly with you just to give you a little refreshment. If you still have issues with it, we can talk about it during the Zoom meeting, and we can go a little bit more in depth. But this is just the basics of it. So the first thing you need to know is this. Write this down somewhere. So that you can have it later on, all right? Multiplying and dividing, all right? This will help you out. This is with negative and positive numbers. And this is a good way, one of the teachers here found, to help you remember. So if you're multiplying or dividing two positive numbers, you are going to have a positive answer. If you multiply or divide two negative numbers, you're still going to get a positive number based on the smiley face. But if you multiply or divide a positive and a negative, you're going to get a frowny face. Same thing, if it's a negative times a positive. All right? So this is just a quick way to try to remember this. Multiply two positives, positive. Multiplying two negatives, positive. Multiplying a positive and negative, that's a frowny. And a negative times positive, that's a frowny face also. All right. This is just a quick way to remember that. And I'll give you an example of each. So if you say 3 multiplied by 2, both positive numbers. So what's our answer going to be? It's going to be positive, negative. It's going to be positive 6. Multiply two negative numbers. Negative 3 times negative 2. All right? Negative, negative. What's my answer going to be? Positive. Positive 6. As you can see, no matter what, if these two are the same, positive, positive, or negative, negative, you're going to get a positive answer out. But now if you come over here, say I make the 3 positive and the 2 negative. Based on the frowny faces underneath it, what are you going to have? Frowny faces are usually negative. Negative 6. Same thing if I switch it around. It doesn't matter which one's negative as long as one of them is negative. So if I make the negative on the 3, you still get negative 6. The same goes for division. All right? If you have two positives in division, positive answer. Two negatives, positive. So write this down somewhere so that you can have it. This is the best way I've seen it written out. It's a real easy way to remember it. Even though it's a little elementary school type stuff, just write it down. So sticking with the idea of multiplying and dividing positive and negative numbers, all I did was take what I wrote here and I just moved it up here so I could come back to it as we're doing these problems. So we're going to do a couple of multiplying and dividing problems just so you can sort of see how it works a little bit more. More examples you have, it's always better. So the first one we're going to do is negative 6 times negative 5. And now how we talk, you could say negative 6 times negative 5, negative 6 multiplied by negative 5, however you want, all right? But you know it's a negative and a negative. So I'm going to come over here to my chart, all right? They aren't positive, so negative, negative, smiley face. So what's my answer going to be? Positive. So negative 6 times negative 5. If you just want to go ahead and write it there at the end, so you don't have to worry about the sign anymore, go ahead. No problem with it. Then 6 times 5 is 30. Now, you don't leave the positive sign there because it won't show up on any of your work. There you go. Negative times negative, positive. All right. The second example I'm going to show you is a division one. Negative 6 divided by 2. So this might be new to some of you guys. You might have seen it before. You might not just remember. You've been out of school a long time. right? This is how I'm gonna write all my division problems this year, if you come to watch these videos. Because this is how it looks for probably the rest of your career. You're not gonna see the quotient sign very much anymore, so this just works out better. So -6 divided by 2. All right, so I have a negative and I have a positive. Now look, I'm gonna go down my list. Positive, positive, no. Negative, negative, no. Positive, negative, no. And I'll say negative, positive. Okay. Frowny face. So my answer I already know is gonna be negative, because I have a negative and a positive. Then all I have to do is take 6 and divide it by 2, which is 3. And there's your answer. It's that simple. Now, what happens every year is people get confused between multiplying, dividing, and adding and subtracting. When you do adding, subtracting, you do not use this chart, right? It's only with multiplying and dividing. I'm gonna show you one more multiplying and one more dividing problem, and then we'll move on to addition and subtraction, where you do not use this. So again, this is only used for multiplying and dividing. So your third example, we'll do let's say 2 times, or we'll put it in the new way, -5 equals what? And again, what is this? This is a equation, this is an equation, because it has a equal sign. So 2 times -5. So I have a positive and a negative, I go down, that's a frowning face on my list. So I can just go ahead and put the negative there. Then 2 times 5 is 10. There you go. All right, and then we'll do a division problem. We'll say 20 divided by -2. We'll make them both negative this time. So I go down my list. Positive, positive, no. Negative, negative. Negative, negative gives me a happy face. So I know my answer is going to be positive. Then all I have to do is divide 20 divided by 2, and that gives you 10. And it's just that simple, right? As long as you can remember this and that it goes with multiplying and dividing, the rest pretty much falls into place. It's just having to remember that and ingrain it into your mathematics skills. That requires some time, but once you do, gravy. Right, now we're going to talk about adding and subtracting. We'll just keep going with it. Erase all of this. Notice I am erasing my little chart that I have. You do not use that chart with multiplying and dividing, or you use it with multiplying and dividing, not with adding and subtracting. So now we're just going to do some addition and subtraction problems. We'll start off with something very simple. 6 minus 2 equals what? So I have 6 things, I take away 2 things. 4. Pretty basic. Now what if I did this? What if I took the negative from the 2 and put it on the 6? All right, is the answer still 4? No, it is not. Because now this is a completely different problem. So if I have -6 things and I take away 2, or I add 2 to a negative, I have negative, right? If you'd like to look at this, there's another way to look at it, a number line. So -6, -5, -4, and -3. So my -6 is right here on the number line, all right? And this is where it gets a little bit confusing with the negatives, because you go a different direction. So -6, and if this makes no sense to you, just completely ignore it. So -6, then I add 2 to it. So 1, 2, my new answer is at -4. So now we'll do -3 minus 5. This, you have 2 negatives, all right? So if you have 2 negatives, you know instantaneously your answer is going to be negative. When it comes to adding and subtracting, again, do not use what we use for multiplying and dividing here. So -3 minus 5. So if you want to go back to number line, if that's your thing, if it works for you. So I have -3 things right now. And I'm going to move it -5 times. So 1, 2, 3, 4, 5. Answer is -8. If the number line works for you, go ahead. Just remember, this is the negative direction, and this is the positive direction. So here we start at -6, I added 2, so in the positive direction. All right? And the last one we will do is -20 plus 2. So if you want to go back to the number line thing again, you can. But let me ask you something just for your thought. If this number is -20 and it is bigger than +2, what is your answer going to be using your logic? It's going to be negative, because the bigger number is negative. All right? So if I do the number line, I put -20, -19, -18. So this is my negative direction, this is my positive direction. I start here at -20, and where am I moving? I'm moving the negative direction? No, because I have a plus sign there. So then I move that 2 places, and that gives me -18. So I hope this was a little bit helpful for you. All right, I know this is a super long video, but I needed to talk about that integer stuff and make sure you guys understand the difference between multiplying, dividing, and adding, subtraction using positive and negative numbers. So now we're going to do some problems that are actual equations using variables. Okay, this is a little bit different. People do this different ways. You can do it another way if you find a way that's good for you. But my way is this. Oh, this is a number, this a letter, and this is a number. And at the equal sign, you make a wall. All right? Anything that goes over the wall, you have to do what's called an inverse operation. Right? An inverse operation means if I'm subtracting, I add. If I'm dividing, I multiply. All right? Here, I have a -6 plus x equals 4. So since I have a -6, I have to combine it with my other number. The trick here is just remember that everything wants to be with its like. So I have a number here, and I have a number here. So this -6 wants to go be with its family, but it has to get over this wall. But to go over the wall, you have to use the inverse operation of what is happening. So if you have a -6 here, or it's basically subtracting 6 from x, what is the inverse operation? Adding. All right? So now, what's -6 plus 6? It's 0. And then what's 4 plus 6? 10. So x equals 10. So all we did here was we add 6 to both sides. That's your first problem. I like to label it number, letter, number. That gives me a better idea of what I actually have to combine, because some of these problems are rather large. X plus 7 equals -3. I draw my wall and I make my labels. So this is a letter, this is a number, and this is a number. So the numbers want to go to their family. But there's this blockade. So we're going to use x plus 7. So how would I get that 7 across the wall? I have to use an inverse operation. So what is the inverse operation of plus 7? Subtract 7. So all I'm going to do is subtract 7 from both sides. And that gives me, what's 7 minus 7? 0. And since 0 doesn't matter, it has no bearing, we can just get rid of it. Then it's negative 3 minus 7. So just stick with it. I'm going to stick with the number line in case some of you guys like it. So I have negative 3 things. This is my negative direction, this is my positive direction. 7, 1, 2, 3, 4, 5, 6, 7. So what is that? Negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Negative 10 is my answer. So now we have a third problem. This deals with multiplication, because that's what's being done here. It's just another way of writing multiplication. This is negative 7 times x equals negative 49. So this is where we need our smiley faces and our frowny faces, because now we're dealing with multiplication and division, negatives and positives. So I draw my wall. Now I have a number and a letter combined, and another number. This number wants to go be with its family of other numbers. So what operation is being done here? I already told you it's multiplication. What's the inverse operation of multiplication? Division. So we divide whatever the number is away. But you divide it from both sides, because whatever you do to one side of the wall, you have to do the other side of the wall. That is always the case. Whatever's done over here has to be done over here. So then we divide negative 7 from both sides. All right, so negative 7 divided by negative 7 gives you 1. Since the 1 is just understood that's there, you can take it away. So x equals. So we have a negative and a negative. If you remember, a negative and negative still gives us a happy face. So I know my final answer is going to be positive. Then 49 divided by 7 is 7. And that is your answer. So we have to build our wall. And again, this is a division problem. So what's the inverse operation of division? Multiplication. So I have a letter on top, a number on the bottom, and a number over here. So I need to get this number over to here. So since what's being done here is division, we have to use multiplication. So what would I multiply both sides by? Well, whatever's on this side. So I multiply this side by 6, and then I multiply this side by 6. So what that gives me is the 6 and 6, they'll cancel out. Don't overthink it, just cancel out. And that leaves me with x left. On this side, we have a negative times a positive. So a negative times a positive gives us a frowny face. So negative, so it's frowny face, so it's going to be a negative answer. 5 times 6 is 30. And that is how you do it. There's many more examples in your work, and you can find a lot of this stuff if you need more examples online. But we can also talk about the Zoom meeting if you're still having issues with it. This is the basis of really what algebra is and what the rest of this year is going to be. You have to get this down if you want to be successful in this class. If you're struggling first, it's all right, because we'll figure it out together. So don't worry about it. Just work hard at it and do a lot of practice problems. If the only practice problems you do are the ones I do and that are on there, you can't become proficient at it. Just work a little bit harder at it, and you'll be really, really good. It'll set you up for the rest of your high school career. And that is all this video. I know it's super long. Thanks for hanging in there.